Welcome to my channel. I'm Zhang Jingxu. Let's talk about the problem 24 at chapter 3. In this one, this is still the combination about the vector and the motion. So we can consider the motion in two directions. Let's see what it tells us. It tells us a particle starts from the origin. So at the initial, it is stationary, right? With the initial velocity, this one tells us the velocity, but wait, tells us the velocity is at the x direction. So the velocity is only at the x direction, the y direction is 0. So we can write it as 5.0 I. And then we get the acceleration, still a vector in two components, I component and j component. There we need to pay a little bit of attention on this I component. There is a negative sign. See? Negative sign tells us this vector or this acceleration just make the x component slow down, and stop, and then accelerates at the backward. Agree? And then determine the velocity and the position of the particle at the moment it reaches to the maximum x component. Now, question: when it reaches its maximum x component? So we can just consider the motion at the x component. We can see the initial is 5.0 meter per second. And then it slows down, right? Because the acceleration is negative. Slows down, then stop. After it stops, it accelerates backward. See? Do you agree? So there must be the point it reaches the x coordinate. When it reaches the maximum x coordinate, that means that Vx equals 0. Agree? So we can write the equation for x component and y component. First thing we can consider, this one, we know the velocity is initial velocity plus the acceleration times the t. We write this equation in two components, I component and j component. So we write the initial is 50 I component plus the acceleration. Therefore, we write it inside. We find at the velocity at x component is just 5.0 subtract 3.0 t. And there, we see when it reaches the maximum x component, the Vx equal to 0. We find the time t. Agree? We find the time t. And then after we find time t, we input the time t inside. Because Vx is get, and we input the xt inside, we get the velocity. For this one, it's just has a j component. The next one, we need to find the position. So for position, and this one, we know initial velocity, we know acceleration. It's super easy for us to get the position. See, final position equals initial position plus initial velocity times t 1/2 at squared, we know, and then we input it in the vector format. This one is 0. And then we know t, so it's 5t. And this one 1/2 at squared, so we input the a in I component and j component. Finally, we find it is just a vector. And then we input the time t inside, we get it. This position is still a vector. Thank you.